Welcome to this pre-algebra tutorial on solving equations using addition or subtraction. Your goal or objective, same thing, two different words mean the same thing. By the end of this tutorial, you will be able to solve equations and word problems in one variable using addition or subtraction. In order to do so, we need to learn the subtraction property of equality and the addition property of equality. The subtraction property of equality is as follows. In words, it means subtracting the same number from each side of an equation produces equivalent equations. So using numbers, that means if I take x plus 4 equals 5. If I subtract the same number from both sides of the equation, if I subtract 4 from this side and I subtract 4 from the other side, I get equivalent equations. So I can subtract the same number from both sides and get equivalent equations. And so if I subtract this 4 from the left side, positive 4 minus 4, that goes away. That just leaves me with x. So that equals 5 minus 4, which is just 1. So that's one way of solving an equation. We subtract the number from one side to get the variable by itself, and then that gives us our answer. Our justification for it, we're able to do it because of the subtraction property of equality. This is one to definitely remember. This one comes up over and over. It never stops appearing in math and in algebra especially. It works for variables as well. If I had a plus b equals x. So if I wanted to solve this for a, I would subtract b from both sides, and that doesn't change the equation. It produces equivalent equations. And so I could subtract b plus minus b plus b. That just gives me 0. So all I'm left with on the left side is a equals x minus b. We see that it's very easy when we're just dealing with numbers over here. But when we're dealing with variables, we need to know the rule. And so the subtraction property of equality will help you when you're dealing with variables especially. So let's look at some examples. We have x plus 6 equals 12. We want to use the subtraction property of equality to solve this. So we need to get x by itself. If we do the opposite of this, positive 6, we can get x by itself. So the opposite of positive 6 is negative 6. X plus 6 minus 6 equals 12 minus 6. Adding the negative 6 to both sides, so x plus 6 minus 6 is just x. That equals 12 minus 6, which is 6. Let's look at another example. If I have a negative 2 equals z plus 5, I want to solve this for z by the subtraction property of equality. I have negative 2 minus 5 equals z plus 5 minus 5. The 5's go away on the right side. All that's left is z. Negative 2 and negative 5 is just negative 7. So z plus 5 equals negative 2. That means that z equals negative 7. And you can easily check it. Negative 7 and positive 5 gives us a negative 2. So that checks out. Same for the first example. 6 plus 6, we know that to be 12. In mental math, we can see that easily as well. You can do this using mental math as well. The easiest way is mental math, but if you're required to use this rule, then this is how you use the rule. Feel free to pause the video and try the following example. 21 plus m equals 5. By the subtraction property of equality, we want to get m by itself. We have a positive 21. We can subtract 21 from both sides because we know if we add opposite numbers, that equals 0. So positive 21 and negative 21, that goes away. We're left with m. And we also know that if we add the same number, if we subtract the same number from both sides, it just gives equivalent equations. So 5 minus 21 is negative 16. We can back check that, and we'll see that 21 minus 16 is in fact 5. This is a good spot to also pause the video and try the following example. Q plus 7 equals 57. Okay, if you pause the video and you said Q plus 7 minus 7 is equivalent to the original equation. Q plus 7 minus 7 equals 57 minus 7. That's an equivalent equation to the first equation. When we add the opposites, the numbers go away, so all we left with is Q on this side. 57 minus 7 is just 50. We can easily back check it. If we substitute Q for 50 for Q, 50 plus 7 is in fact 57. And so in understanding the subtraction property of equality, the addition property of equality is very similar. In words, adding the same number to both sides of an equation produces equivalent equations. So if I take x minus 2 equals 5, what it's saying is that I can add negative 2, I can add positive 2 to both sides and not change the equation. In fact, it's when I say not change the equation, I mean that it's an equivalent equation. When I add opposites, those numbers go away. Minus 2 plus 2 goes away, so I have x equals 5 plus 2, which is 7. And we can back check it, substitute x with 7, and we got 7 minus 2 equals 5. In algebra, if I wanted to try it algebraically, I could write x minus a equals b So I can say x minus a plus a equals b plus a. I've added a to both sides just so that I can solve for x. So x equals minus a plus a goes away. X equals b plus a. And as we can see, just as in the subtraction property of equality and the addition property of equality, it's easy when we're using basic numbers, but not so easy when we're using variables. So we have to know this property, especially when it comes to variables. So let's look at some examples involving more than one number. We want to solve this for a. We have a plus 5 plus 8 equals 21. Now, remember the first rule, we combine like terms. So the like terms here are 5 and 8. So that equals a 5 plus 8, 13 equals 21. We want to solve this for a, get a by itself. We can add the opposite. When we add the opposite of a number, the numbers go away. So that's what we want to do. We take a plus 13 minus 13 equals 21. Minus 13 goes away here. All we left with is a. That equals 21 minus 13. I know that to be 8. If I back check it, 8 plus 8, 16, plus 5, 21. That does check out. So it is important to know your basic arithmetic. The better you are at basic arithmetic, the better you'll be at all these other skills that you have to learn. All these skills build upon each other. The good thing is, the more you use your basic arithmetic, and not the calculator, if you use basic arithmetic, your counting skills will really get better and better and better because you're constantly using them. But if you never use them, they'll never get better. So use those. Try to avoid the calculators, until you really get strong with addition, multiplication, all of these skills. You want to get strong with these skills before you start using calculators. Those are my, that's my opinion. That's been my experience. Let's look at another example. I want to take b minus 6 minus 1 equals 5. b minus 6 minus 1 equals 5. I want to combine like terms. My like terms are negative 6 and negative 1. So a negative 6 and a negative 1 is a negative 7. That equals 5. Now I want to use the addition property of equality. I want to add the opposite. That's the easiest way. Well, it's one way of solving these problems. You can use mental math on this at this point. But if you wanted to show all your work and you're asked to do it this way, then this is how you would do it. Plus 7 and minus 7 goes away. B equals 5 plus 7, which is 12. 12 minus 6, what we're saying is 12 minus 6 minus 1 is 5. 12 minus 6 is 6. 6 minus 1 is 5, so that does check out. One good thing is when you check your work, if you're able to check your work really quickly, you can be assured of your results. Let's look at a geometry example. It's good to work these problems. These problems become very simple once you work these problems and you get familiar with seeing them. Remember the basic rules. Perimeter. To find perimeter, there's a number of different ways to find perimeter, but the easiest rule to remember is you add up all the sides. Perimeter is the outside. So you add up all the sides. If I took this triangle, and I wanted to know the perimeter. Okay, I have this side is equal to 10 centimeters, here 14 centimeters, and the total is 34 centimeters. I want to find this side here. Okay, I'm going to add up all sides. I know I have. I'm going to say P for perimeter equals, let me just go with dot dot because I'm going to use the equals on the other side. So I have 10 plus 14, I don't know x, plus x equals 34. And so now your basic algebra comes in. We combine like terms first of all. 10 plus 14, 24, plus x equals 34. We add the opposite. That is, we use the subtraction property of equality, and we can add a negative 24 to both sides by the subtraction property of equality. The 24s go away, so x equals 34 minus 24, 10. And so the perimeter is 34. We know that. We know the perimeter is 34, so we just needed to know x. 10 plus 14 is 34. So that does check out. Let's look at another example. What if I took another triangle and I had 22 centimeters here. I have 14 centimeters here. I want to know x when my perimeter is equal to 59. So I have 22 plus 14 plus x equals what? 59. And so from here you pause the video and solve this part yourself. If you said I'm going to follow the first step and combine like terms, 22 plus 14, 36 plus x equals 59. Subtraction property to get the opposites here. Those 36's go away. X equals 59 minus 36, 23. So x equals 23. We know the formula for perimeter is we add all sides. So you tried the following example. Our perimeter equals 351 feet. And here we said x equals 23 centimeters. We got to put the units for completeness. Here 10 centimeters. But for this example, we're going to take, I can write a better rectangle than that. We're going to take this rectangle, not much better, but it's going to work. I have 110 feet here, and I have x. Now there's a little trick to this one. It's a rectangle, so we know a rectangle has two sides, two equal sides. So this is x. Feel free to pause video and finish the rest of this. Okay, if you said this side must be 110 in feet, then you are correct, because a rectangle has two pairs of equal sides. And in the perimeter, we're going to add, the simplest way is just to add all sides. So we know the perimeter does equal 251. I have 110 plus 110 plus x equals 351. 110 plus 110. If you said you combine like terms, that means you combine 110 with 110 to give us 220. X plus x is 2x, not x squared, but 2x. Because x is just 1x, so 1x and 1x is 2x. That equals 351. I'm going to use the subtraction property to rid myself of this 220. Running out of space here. Okay, so that goes away. I have 2x equals 351. I'm just going to write this 351 minus 220. So I have 351 minus 220 is just going to be, I have 2x here. That equals 131. Yeah, 131. So I know on this left side, my 220s went away. When I add the opposites cancel. So I'm left with 2x. 351 minus 220. If my algebra is correct, if my addition is correct, that's 131. So x, we divide both. So x, we can divide both sides by 2. So x equals 131 over 2. Let's continue on with the word problems. Word problems become easier the more that you solve. And they're nothing to be afraid of. We just solve them as we go and keep working at them. And then you see the patterns on how you solve these. You always solve these. You break them down. Most of these problems are fairly simple. They start off fairly simple. In this case, you are making a blanket and have $200 to spend on materials. To make the main body of the blanket, you buy 5 yards of solid color fabric for $3 per yard and 12 yards of printed fabric for $8 per yard. You also buy 5 yards of batting, which is material used to stuff the blanket, for $11 a yard. How much can you spend on fabric for a decorative border? Now you read it the first time, then the second time through, you break it down into parts. So you just read through it the first time. Now I see what they're trying to do. What they're asking us is, we're going to add up these individual parts, the solid cover fabric. We're going to add up what we spent on that. We're going to add up what we spent on the printed fabric. We're going to add up what we spent on the batting. We're going to put those values together and see what that comes up to. Whatever's left over is what we'll have left for the decorative border. Okay, so let's start. You have 5 yards of solid color that fabric that costs $3 per yard. So the way I would write that would be, I had 5 yards, so that's going to be 5, and I know it was $3 per yard. So that's times 3. I know in the end, it's going to have to add up to what? It's going to have to add up to 200. So I'm going to have 5 yards at $3 a yard. And I'm going to add. I'm going to do the same way all the way down. So it becomes very simple all the way down. I have this printed fabric. Oh, this shouldn't be a dollar sign here. So this is 12 yards of printed fabric at $8 per yard. Then I have 5 yards. All of this is added, 5 yards of this stuffing for $11 per yard. Plus whatever is left is going to go towards the decorative border. So I'm going to make that X. And I don't know how much I have left for X. They're not asking me how many yards I'm going to buy. They're just asking me how much I have left. So we know that's equal to 200. $200. So 5 times 3, 15. 12 times 8, 96. 5 times 11, 55. Plus X equals 200. We'll convert this back to dollars in the end. It's easier to do it that way. We could put the dollar signs in it. Either way, it doesn't matter. I'm going to regroup these. I'm going to combine the easy numbers together. So I'm going to go 15 and 55 plus 96. Associative property of addition, so I can move these numbers around without changing the problem. 55 plus 15 are easy to add together than 55 and 96 or whatever. So that's 70 plus 96. I want to make sure I don't run out of space here. Plus X equals 200. Getting close. So 70 plus 96, I know that to be 9 plus 7, 160, plus 6, 166, plus X equals 200. Okay? So I can use mental math on this one, and I know my answer to be 34. But I'm going to go over here. I'm going to create some space and go over here and work it out. I have 166 plus X. I'm going to go at negative 166. I'm going to use the subtraction property. Plus 166 plus X equals 200. And subtract 166 from this side. So I added opposites. Those are going to go away. X equals 200 minus 166. As I said, I know that to be 34. If I wanted to check it, 15 plus 96 plus 55 plus 34. I'll leave you to check that. That should equal 200. So what have we learned? We learned that we can use the subtraction property of equality. Subtraction property of equality says subtracting the same number from each side of an equation produces equivalent equations. We can do that with numbers or with algebra. In the same fashion, the addition property of equality, we can add the same numbers to both sides of an equation that produces equivalent equations. So in numbers, you can see it's very easy, but in algebra, we definitely have to rely on the rule. But the same way we can do that with variables, algebra, you can do X equals B plus A. You can solve that one just based on the addition quality. The addition property of equality. And so we can extend those same concepts when we have more than one term in our expression. We just follow our basic rules. That goes back to combining like terms. Once we combine like terms, then you're likely to have a situation where you can use the addition property of equality or subtraction property of equality to solve for the given variable. And we use those properties in the dreaded word problems. These word problems get easier as we work with them. So we took a look at a geometry application. Perimeter, add all sides is the simplest way to do perimeter of any figure. We have two sides given for this first triangle. We have X missing. So we just plug in the sides that we had. We had 10 plus 14 plus x. We knew the sum was 34. We did the basic algebra and we found that x equaled 10 centimeters. Same for the next triangle. We had two sides and we had the total. So writing it out, we were able to write out, we know perimeters, adding up all sides, we add up x plus 14 plus 22 to get 59. And do those basic rules that we learned here to solve for x. And the same for the rectangle. The only difference with the rectangle is we had to know that a rectangle has two sets of equal sides. If you ever looked at a box, you see that two sides, even if it's square or if it's rectangle, it has two sets of equal sides. So once you figured that out, we had x plus 110 plus 110, total of 351. Did the algebra on that and came up with our answer for x. And finally, we took a look at a word problem. Had a lot of words, but it was very simple once we broke it down. We just used different fabrics to create a blanket. We needed to know how much you had left to buy whatever you needed to buy. And this type of problems, believe it or not, come up all the time when you're in stores, you're shopping for different things. You need to know what you have left over. You need to know how much you're spending. So these are real world this is definitely a real world problem. We just broke it down. You read it through the first time. That's the first step. Read it through the first time. Secondly, you look at it the second time. Now you can break it down and figure out what's being asked. We see that we've bought three different things. We've bought 5 yards of solid color fabric. We bought 12 yards of printed fabric. And we bought 5 yards of stuffing material. And we still need to get the decorative border so that when we put this blanket together, we'll have everything. So you just add those all up. The 5 plus 3 plus 12 plus x. How much did that stuff cost? We need to know. We only have $200. And so x is going to be what we have left. We have $34 to spend on the decorative border if we're going to spend those amounts on the other parts. And that's going to conclude this lesson on addition and subtraction, properties of equality, solving equations using addition and subtraction. Hopefully this lesson was helpful to you. Please like, subscribe, share, support. Thank you for tuning in.